Well, hello again. We're back. Mark Gresham and I, Mark from PSI-PCI, our very handy and very close by expert that we can rely on, that is really plays such an important role. And was somebody was mentioning recently, you know, we do these talks, these presentations, we write the articles. Mark is out there in the industry, and you might ask yourself the question, does it have any impact on what's happening? And one can't kind of get those metrics 100% correct, but I think, Mark, we would say that since we started with, not just us, but other people, started speaking about safety, that we've seen a general decline in the number of incidents.
Absolutely. When our company was founded 40 years ago, it was common to have between 22 and 25 cylinder ruptures, that's just the scuba business, on an annual basis. Last year and 2015, so 2015, 2023, zero that we know of. So that's a tip of a hat to the people that are diligent and trying to understand this information and apply the information. Moreover, question bad cylinders. I'm not sure, so we're questioning it. We didn't used to. We used to just fill it and say what could happen. So in today's world, we've made a remarkable gain in safety by questioning cylinders. It's easy to question a cylinder, set it aside, and don't fill it until we determine it's safe for use.
But let's also be, I would say, from an engineering point of view, they haven't really changed the manufacturing specification. It's not really been a design issue. It's been more a user issue.
Correct.
Anyway, that's just something we thought we would share with you. The topic that we'd like to talk about today, and it's one that always makes me smile when I'm on a stage with Mark, because we kind of approach this thing slightly differently, and that is when to oxygen clean something, whether it's the cylinder or the valve, or more importantly the regulator. And when we say oxygen clean, what do we mean? What does oxygen mean? It doesn't mean necessarily 100%.
Right.
So some people will say oxygen means 99% oxygen. The purists amongst us would say that anything above 21% air or any other gas is essentially enriched air, or what we call oxygen enriched. And where is that line between when should one fill in terms of a percentage of oxygen, and under which value is it going to be, let's say, safer to use? Having said that, Mark, as I think you and I agree with, a scuba cylinder with 3000 psi inside it of regular air has 200 times more molecules of oxygen than an empty cylinder. So we might talk about enrichment. There's loads of oxygen in a filled air cylinder. So please don't be fooled when we talk about oxygen enrichment as the kind of a hazard area. Regular scuba air under pressure can be a hazard too. But let's start this discussion with, and this is not between us, this is really, I think, between the scuba industry and you and I. What do they say out there in terms of when should one be doing O2 cleaning?
Well, the common, and I say it's a misnomer, is using the commercial diving 40% threshold. So if it's greater than 40% as your finished or final mix in your cylinder, then we need to clean it. Whereas the CGA says 23.5% and greater should be O2 clean because of the different methodologies of mixing the gas, which is a common practice of mixing the gas in the scuba cylinder. Whereas in the commercial industry, that's not done at all.
So it does get confusing, and I think a lot of this is driven by the, you call it commercial, actually the, say the scuba industry, the recreational scuba industry where nitrox is used very frequently. They like to use that same rule. What they don't know is the rule wasn't written that way.
Right.
The rule, as published in the Code of Federal Regulations, as you and I know, allows you to use 40% oxygen for low pressure breathing whips, not for high pressure that we have in the cylinder. So I know we do every now and again come across somebody angry with us when we say, actually, 23.5%, 25%. Realistically though, 28%, not because it's more or less safe, but that's when we used to start making nitrox. So you're not going to oxygen enrich anything unless you're going to be doing it for a reason. So 28% is, we know, any nitrox, because it's not going to be less than 28, it must be O2 cleaned. Now, of course, we have people arguing with us, and I, for one, have been in the industry for long enough, both the commercial and the recreational diving industry. When I see somebody using a compressor to compress enriched gas, I always stand away. And they always tell me, you know, what do you know? Well, I think you and I know, we've seen compressors that haven't survived that particular test. But that's how nitrox sometimes is handled. You were sharing with me the other day a case where they were putting pure oxygen into a nitrox compressor with the understanding that the final mix is what determines whether it needs to be cleaned. Is that correct?
Correct. And there's a lot of people that try to use the final mix as the criteria for cleaning, when in fact it's how you get to that final mix is the requirement. There's a lot of people that misunderstand this information. I hate to use the term tribal knowledge, but I think that's what it is. It's John has been doing this for 27 years and he's never had an accident, so it must be safe. When in fact, if it was wrong at the beginning, it's still wrong 27 years later. So caution, putting pure O2 into a hot compressor, ooh, that's foolhardy at best.
Yeah. And you know, the diving industry might be spared to some extent with this, but if I were to open this up and show you what happens in the healthcare industry, especially home healthcare, where people are using oxygen concentrators and so on, we see fires. It's not that uncommon. Of course, as you know, Mark, we can take those three elements. We can get the oxygen, we can get the fuel, we can get the heat, we can put them together and nothing happens. And we can do it again and nothing happens. But usually by the 10th time, if you've got the mix right, it's going to burn. So because it doesn't always burn, we kind of develop this sense of false security in it. So, okay, so we say, and I agree with you, anything where there's going to be enrichment, I don't need a percentage. In fact, I say to you, if it's more than 21%, somebody's added something, and when they've added something, it's now essentially oxygen enriched. But for applications in nitrox and other elevated oxygen percentages, we need to O2 clean. So Mark, a question for you. Should we, as individual people at home, be doing O2 cleaning, or should we give it to a professional outfit to do? Can I do it at home?
You can do it at home, but it's better to give it to a trained professional, somebody that has been trained to the standard, applies the standard correctly, and does this with regularity. Somebody who does it with regularity is less likely to make errors. But an individual can O2 clean. It's not complicated as long as you follow that protocol and use the checklist so that you in fact verify that you've done the requisite steps.
So why would you O2 clean at home? What have you done to require O2 cleaning to take place?
Well, in O2 cleaning, CGA, Compressed Gas Association, publication G4.1 specifically states equipment. It's an all-inclusive statement. What's kind of strange about it is they don't delineate whether it's a filling station, a cylinder, piping, hosing, and tubing, et cetera, et cetera. It's all-encompassing. So if you're going to use enriched air, nitrox, at any percentage, and I agree with you, greater than 21%, cleaning is a really good idea, and forget trying to say, oh, it's exactly 23.5%. We know we're going to use it for enriched air, so clean it. Clean everything. And that way you've taken a prudent look at what you're doing, evaluated it, cleaned it, inspected it, made sure that you've met the standards. It's not complicated to do. It takes training, though. It does require formal function-specific training.
So I asked the question because do you have nitrox cylinders at home?
Yes.
How do you handle them? Do you touch the valve surface with your hands?
Well, unfortunately, the handle is the valve.
But we touch the mating surfaces without thinking. We have an oxygen resuscitator kit. We pick the cylinder up by the valve. So our fingerprints get onto the outlets. And we know that fingerprints and other dirt are readily accessible fuels if you get the mixture right. But we don't get many fires that way, although we do, right?
There's enough.
So I would say, from my point of view, that I would not encourage people to O2 clean at home. I would suggest that they get it done professionally. Maybe for them and their own risks, you know, it's one issue, but all it needs is somebody else to pick up that cylinder and use it. And we had a very, very famous case here in the US several years ago where somebody died as a result of an explosion. There are many, many factors in this case that make my hair stand on end. So I don't agree with the judgment that was given, but that's just because I tend to be a bit more pragmatic than emotional about these things. But in essence, what it came down to was that the O2 cylinder being cleaned by somebody that professed they could O2 clean. And because they didn't have a piece of paper that said you certified to O2 clean, and there was a fire, which they couldn't link necessarily to the two, that person lost the case. So I would caution you, if you're going to be doing nitrox diving and you're concerned your cylinder's been lying in the back of the car, your regulator might have been lying somewhere, I would certainly wipe it down. And if you want to know what you can use regular dishwashing liquid as long as it has no additives. So no
Correct.
perfumed dishwashing liquid. Make sure that you rinse it off thoroughly afterwards. But that's really going to be an in-the-field type clean. When it goes into a place that does proper oxygen cleaning, they have a bunch of criteria. You mentioned the CGA specification. There are various other ones. But they'll be using very dedicated solutions.
Correct.
And then, really importantly, is when they're done, they will inspect it.
Right.
To make sure that we visually can't see any signs of contamination. Now, just kind of to understand that in context, we're not looking for parts per billion of anything.
Right.
We're just really looking for what we call ppm, parts per million.
Right.
And if there is any oil or dust or debris in there that fluoresces when we use a UV light, that's pretty much good enough for you. Would you kind of concur with that?
Yes, I agree. And to add to what you said earlier, if you have 3 cylinders or 4 cylinders and you O2 clean every 5 years, you're not a studious O2 cleaner. And to back up what you said, I totally agree with the fact that we should take them to a person that does this on a regular basis, has a facility, the requisite tools, cleaning materials to do this. A much more thorough process than the person that does this occasionally. While it's easy to do, it's best done by somebody who does it with some regularity.
But I guess in practicality, the only time you're going to take the valve out the cylinder is when it has its annual visual.
Correct.
And usually you're going to give it to somebody that's trained to do
Correct.
a visual, and they then should be the people making this decision.
Correct.
We shouldn't at home decide, maybe I have some oil in the cylinder because it wasn't tasting great, and you do this yourself. It's
Right.
not a good idea for you to. If you suspect any form of contamination, take it to somebody that knows what they're doing.
Correct.
Don't try and remedy that yourself. So of course, as you say, I guess the training that's required to do successful oxygen cleaning is not onerous. It doesn't require
Correct. somebody
to be hyper intelligent. It's very diligent though, and very, very systematically done to make sure that you don't end up with any contamination. There are many things we can talk about, and some of the things I sometimes smile. I see these O2 inspection lamps and things, and I think to myself, I'd like to catch them out. I'd like to go and take a bit of crystal lube or some lubricant and wipe it on a thread and say, right, will you inspect this for me? Because they're not going to see anything. And they're going to think there's no hydrocarbon or no grease in that at all. It can get complicated, but we're not trying to do super semiconductor safe oxygen cleaning. What we don't want is to have enough fuel to sustain a fire. So if it's microscopic, sure it can burn, but it's not going to then lead to some catastrophic failure. So it's not really contentious. It's just kind of that purist discussion, and where it comes from me is you're not going to intentionally add oxygen to anything unless you're going to go to 32% is really where most nitrox diving is.
Right.
You need to O2 clean for 32%.
Correct.
And the 40% myth, please do not put 40% nitrox in a system that hasn't been properly cleaned, and please don't bleed 100% oxygen through the compressor to make nitrox. So some practical things. I mean, it's an industry where we've seen things happen, and most of the time it's taken a lot of digging around afterwards to figure out where the problem actually occurred. Oxygen supports combustion very rapidly under pressure. If you try to light a fire in a 200 bar cylinder, let's say you manage to do that, it's going to burn about 10 times faster than it would sitting here on the desk. Purely because there are more oxygen molecules.
Correct.
There are more nitrogen molecules to dampen. I know people argue about these things, but we know that under pressure in hyperbaric chambers, for example, things in normal air burn a lot faster and a lot hotter.
Absolutely.
So please keep those questions coming. Keep your interest so that we can share it with other people, and we'll be back with some more things to share with you. And thank you, Mark, for your time.
Appreciate the time, sir.